In this video, I'll be showcasing on how to get started with animated Java. The timestamps should be on the screen right now, so if you want to jump to a specific part of the video, then be my guest. So in front of me, I have a standard animated Java model, and apart from some minor differences, it should actually be almost at the exact same as a Bedrock model, with I think probably the most major difference being the rotation limit that Java models have. So because I'm doing this tutorial, I have the models, the texture, and the animation prepared. And if you do as well, then you can head over to this new menu and click on the settings, because that's where the important stuff happens. So let's start at the top. We start with the project name, and as the description says, this is the unique ID of your project. And this project name basically acts as a sort of namespace to your project. So I recommend setting this to something descriptive. So in my case, that would be a mech, since this is supposed to represent a mech. I don't know if you can see it or not. So then we head over to the exporters. There are currently two exporters in animated Java, which is the statue exporter and the animation exporter. And as you can tell by the names, the statue exporter exports a statue, so that's without animations, and the animation exporter exports with animations. And that's probably what you've all seen in a bunch of videos that's been posted about animated Java. So then we head over to arguably the two most important settings, in my opinion, which is the rig models export folder and the rig item file. So when we start with the rig models export folder, you can basically select a directory, and this is the directory all of animated Java's generated models will be dumped into. So this should be a directory in your resource pack in the models folder, and I'll be putting this in models slash items slash item and then slash the name of my project. It's very convenient to put it in a separate folder, because if you have multiple rigs, then your folders are organized by those rigs and you don't have a bunch of files randomly named in your directory. So I'll be selecting this file, this folder. Then we head over to the rig item file. This is the vanilla item model file where all of your custom model data predicates will be put onto. So of course this should be the name of an actual vanilla item, so don't name this blah blah blah.json. I think by default animated Java selects white dye, but I prefer purple dye. And so I'll be selecting that. Make sure to put this in the model slash item slash folder, so it actually becomes the model. This should be relevant for the tutorial, since I don't want to make it too long, but you should be able to read this in your own time or ask a question in the support channel. The animation cast should probably always be enabled, since it makes exporting a lot faster the second time, since it basically caches, sort of saves the animation you did from the previous export. So if you haven't changed that animation, it won't change it the second time you export. The bone size limit box is a setting which it has a drop down. You can select single, multiple, and disabled. And disabled will not show anything. So in this case, there's no red box. But if I set this to single, you can see there's a red box here, which indicates the area which I can put my elements in of that bone. So each bone would have a different, I believe, bone size limit box, as it says there. And if you select this to multiple, you can see there are different boxes for each bone, which indicate how big each element can be. Anyways, moving on. So we head over to the exporters, and we're going to skip over the statue exporter since we're doing the animation exporter now. And there's a bunch of settings you can customize here, which I recommend reading in your own time, but to keep the tutorial short, I'll be just scrolling down to the bottom to export mode. So there are two export modes in animated Java, which is MCB and vanilla. So unless you're familiar with the MC build compiler or langMC um, syntax, I recommend just selecting vanilla, which will export a vanilla data pack. So of course you have to select a directory, which I prepared. So the directory you select should be the data pack itself. So in my case, that would be data pack slash and then the data pack name, and then this folder. In this folder, basically, animated Java will put the pack.mcmeta and the data folder. So we've selected all the settings and we should be ready to go. So if we try to export, you can see it starts going. However, it hits an error, and that is because the textures I have aren't saved to disk. So I recommend saving them to disk first before you export. So I guess if I head over to this directory, in my resource pack, of course, item, and I'll be saving this. So after we've saved all the textures to disk, we can try exporting again. And as you can see, the animated Java prompts you with this prompt, which says this folder does not contain any existing rigs. And this should be completely normal if this is the first time you're exporting to a new resource pack. So I just click confirm, and it should generate the data pack. So we've exported successfully, which means it generated the resource pack and the data pack. So we can head over to Minecraft. And firstly, we'll be selecting the resource pack. I call this AJV2 tutorial. And the data pack is already in the world, so I can just reload. In this part of the video, the second part, I'll be showcasing how some things work in animated Java, and I'll be showcasing some extra features animated Java offers. So first, let's start off with the model variants. I have an example prepared where I have this mech and I have a light that I want to turn off and on while I'm in game. So for that, we can use model variants. So model variants are basically some sort of like variant your rig is in, which changes the textures. So let's just get on with the example because that's probably the easiest to understand. So let's say I want to turn this light off and on. I want to create two states. One I'll call light off to be descriptive. Then I'll be selecting the light off.png for this texture. So I'll be turning the default, so the default texture I have applied to the cubes will turn into this texture, and it'll keep the same UVs. So if I close this, you can see the light turned off, and we'll be creating another variant, which we'll call light on to turn the light on. So we'll be editing this state, and we'll be saying, okay, floodlight lamp on. I want to leave this on lamp on. So now you can view the variants you've created using the eye icon, and it's very helpful because that way you can see what textures you've applied to um, each variant. Secondly, I would like to discuss bone MBT. Each bone has a config which you can change, and the current option is the bone MBT. And this is basically the MBT of the armor stand that represents the bone in game. So in my case, I've already prepared an MBT example for the seat, where I will be putting a passenger minecart on top of it, so it'll be mountable in game. So I'll be clicking the bone config, and then as you can see, I've added some MBT to include a passenger, which is a minecart. Just keep in mind that your MBT should always be encased in those squiggly brackets like they are in game. And one thing I should probably also mention is that I used a passenger as an example, but this can basically be anything for an item model. So let's say you want to make this enchanted, you can add MBT to add an enchant to the bone, so this item model will look enchanted. The nice thing about this is that the MBT will merge correctly, so enchantments will work, effects will most likely work, and some other stuff also. The third thing I would like to showcase is how animations work in animated Java. So the way in layman's terms, it's basically animated Java records Blockbench and then replays it back in Minecraft. And this means that um, things like interpolation, the types of interpolation you can use in Blockbench, also are reflected in game. So I guess in some of these animations, I believe I use let's see, I use smooth keyframes and in some of them linear, and this will be reflected in game, which is quite nice since um, that way you can use more stuff and you're not relied on um, animated Java to add all this entire feature set. The last thing I would like to show is instruction keyframes and sound keyframes. They're both basically the same thing. Hey, this is Ancient from the future, and whilst I'm editing this video, I found out that sound keyframes don't actually work. They get completely ignored internally, which means that anything you put into that won't actually get exported. So I recommend just using instruction keyframes. Anyways, back to the tutorial. And these are keyframes which will which will execute commands at certain times of the animation. So in my case, I use it for sound. So as you can see, animate effects, you can see I play a sound at certain times of the animation. And this is pretty much all. So on to the third part of this video. After you've successfully exported your desired model to Minecraft, you should end up in Minecraft right now with the correct resource pack on and in the correct world. So let's reload first to load the data pack. And after you've reloaded, you want to install sort of animated Java into your world. And animated Java has an install and an uninstall function because it generates a lot of scoreboard objectives. And if you want to uninstall your pack, it's very convenient to run the uninstall function since it removes all those objectives. So let's install that, which installs a bunch of objectives into our world. And after we've installed that, we should be able to spawn in our rig and run some animations with it. So to spawn in our rig, we want to type in /function and then mech, which should be the project name. So your namespace is your project name, colon. Then you want to say summon, and then you have two options because we specified two variants in part 2 of this video. And let's say we want to summon one with its light off. As you can see, the light is off. And as you can see, the bone MBT we specified earlier is also there because we specified a passenger, which was a minecart, for this bone. And as you can see, we can actually enter it, which makes it very easy to make mountable entities with animated Java. So as you can see, we can summon one with light off, but we can also summon one with light on. But let's say you want to change the variant to an already spawned model. We can select the rig by selecting the root entity of that rig. So the root entity is, as we specified, a marker. If you've changed that, you should probably know. You can see in the settings, if you go to animated Java, settings, scroll down to animation exporter, and you can see root entity type is a marker. So we specified a marker, and the tag it has should be aj dot and then your project name, mech dot root for me. And let's say we want to change the variant. So let's say we want to both have them be off. So we say set variant, and then we want to say light off. As you see, they both turn their light off, and they both turn their light on. So on to probably the part you're actually looking for, which is most likely on how to play animations. So to play an animation, you have several functions. So let's say we want to play the walking animation. So we say animations / and then the name of your animation. For me, that's walking animation. And then you have a couple functions: end, next frame, pause, play, resume, and stop. Pause pauses the animation. Play starts the animation until the end. And depending on what you specified for your loop, so in Blockbench you can specify loop mode, it'll behave correctly. So I believe for walking, we set this to loop. So if we once we play this, it'll keep looping. But if we set this to, for example, play once, it'll play once and then start back at the start and then stop. So resume resumes the animation from the current frame. So let's say you played an animation, you paused it, and then you can resume it from the current state to play the animation again. Stop completely stops the animation and resets it to 0. Next frame plays the current frame of the animation and advances the time to the next tick. So let's say we want to play the walking animation for both of them. We just select the walking animation slash play. And as you can see, they start walking. And let's say we want to pause them. We can pause it. We can resume them. And let's say we want to reset them to the start. We can say stop. And I believe end uh, does just sort of, let's say you play it and then you end it. It goes back to the start, as you can see. So it goes to the end, and then in this case, it loops, so it goes back to the start. So let's say you want to pause this animation, and you can play a different animation, like let's say maybe not this one because that one was whatever. It's probably not that bad, I guess. My animation skills aren't that top tier, but anyways, as you can see, it walks sideways. So pause, and that's pretty much all there is to get started with animated Java. Also, one thing to mention is that there is a remove function. So let's say you want to remove like a model from the world. And let's say you want to select one of them. So we'll do limit is 1. We're going to say mech remove and then this. So as you can see, this model disappeared. But let's say we have like a billion models, right? And we want to remove them all because we, for example, want to uninstall the pack. We can just say /function mech remove /all. And it removes all of them. Just keep in mind that any passengers you specify in the bone NPT don't get removed. That should be everything for the tutorial. Have fun, and if you want, you can always showcase your creations in the Animated Java Discord.